3 clusters. Safe, single solution, 3 clusters. Put your hand up if you're behind. Yeah? Analyze, classify, hierarchical cluster, safe, single solution. We have said that we are likely to have 3 clusters. Yeah? Continue. Okay. So you will have all the same outputs. The only thing that has appeared, you will see 3 clusters. And now you can analyze where each instance goes to one of the 3 clusters, which is certainly hard to analyze individually. And this is why we will be performing a post hoc analysis. Post hoc analysis will help us to see the differences between the instances based on these attributes. If you remember, we can use a technique which allows us to see differences between instances based on dimensions, categorical variables. What is that method, please? Differences between the instances when we have attributes with several dimensions. ANOVA. So we will be performing ANOVA analysis. ANOVA analysis is a furthering of a t-test. So when we have more than 2 subgroups, we have 3 and more, we are using analysis of variances, ANOVA. This is what you're using for your coursework. And the independent variables can have dimensions, they can be categorical, but we can also use scale level of measurement, but we will be having more than 2 groups. We have 3 clusters. So we need to assign the instances to 3 clusters based on the differences in the averages of between the scores, because we are measuring using the Wallace distance, the similarities between the scores relatively to the means. And because we have 3 groups, we will be using ANOVA method for the continuous data, and you can see they are denoted by a ruler, scale level of measurement. For categorical values, we will be using cross tabulation. So let's perform post hoc analysis. Analyze, compare means, one-way ANOVA, and move in only the scale level of measurement data. Continuous data. And we need to analyze them against 3 dimensions, 3 groups. We have identified 3 clusters. So your average linkage, the cluster 3, the last variable will be the fact. For the post hoc analysis, select Tukey, because the variances are equal. You can we could have tested it when we were performing the cluster analysis for the homogeneity of variances. You will see that it is homogeneous, insignificant, Leaking's test, but I've pre-done it for you, and Tukey is the post hoc. For the options, select descriptive, and you can double check the homogeneity if you want. Don't have to. Descriptive homogeneity for the options. So that is all that we need for now. Post hoc and options. Click OK. Here we are. Homogeneity of variances, Leaking's test, insignificant. So safely use Tukey. Okay, descriptives. If you remember ANOVA test again, revisiting it for your coursework 1, what do we see? We see averages in the clusters, averages for the scores of instances defined by our three continuous variables. So for the self-concept score, you can see that they have formed three clusters with the averages of 23, 40 and 54. We can't say yet whether the differences between 23, 40 and 54 are significant. We're just taking a note that possibly it is significant. There is a difference from 20s to 40s to 50s. Let's move on to days absent last year. We have 9 days, 6 days and 30. Again, possibly all three clusters are significant in terms of differences of days absent, but some doubt maybe between 9 and 6. And finally, anti-smoking campaign attitude, we have 22, 19, 18. Not so obvious, so I'm not sure about these 2 and 3 clusters. Possibly they can be merged together. Okay, let's confirm. Reperform, okay. Analyze, classify. Oh, sorry, not classify. Compare means, yes, thank you. One way ANOVA. Move in all 3 continuous data. Post hoc Tukey. Options, descriptive and homogeneity variance. Yeah? Continue. Okay. So, let's confirm our suggestions. ANOVA test. What do we have here? Why don't I have my post hoc? Let me see.
There's at least one group has fewer than 2 cases.
Because
there's only 1 case.
Sorry, what happened?
There's a warning that says that post-hoc tests are not performed for self-concept score because at least one group has fewer than 2 cases. Group 3 is only 1 case.
Yes, it should be alright. Yes, there is, thank you. We did perform last time, what happened? One group has fewer than 2 cases. Let me see what's happening. Oh, there we are. We didn't select the rewards method. Let's say, we thought we missed something. Just do this. Classify. Method. There we are. Yes, that's my fault. Apologies. Let's reperform this cluster analysis first. I forgot to define the cluster method. Not so long to reperform. So if you go to Analyze,